Good evening, everyone. Welcome to another video in the series of morphometric analysis. In this video, we will talk about longitudinal river sections. So thank you for supporting our work so far. We have already created multiple videos on other important morphometric parameters. So I'll suggest you go and check out those videos. I'll provide the link in the description box. Also, let us know which morphometric parameter you want to learn next. So let's begin by first understanding what is longitudinal river profiles sections and their significance in long-term evolution of landscape. So a longitudinal river section, it is also known as river profile, is a cross-sectional view of a river along its length. Okay, so you see this is the length of the river. Okay, from its source, this is the source, headwaters, to its mouth, where it again flows into another body of water like ocean, lake, or maybe some another river. Okay, so in this digital elevation model, you can see that this river is going through some path along which it is facing different elevation values, different height values, which we will analyze along its length. So this profile, the profile that we draw for a river uh, path, it shows how the elevation, you see this is the elevation, your y-axis, changes how the elevation is changing over its course and helps in understanding various geomorphological and hydrological processes. Okay, you see the path of the river is not continuous, but it has many ups and downs. Okay, so what these ups and downs are, we will see in the next slide. So the factors that affect the shape, now the question arises, why this river has this particular shape, why it becomes flat at some places and there is sudden drop in the elevation. Okay, why it is not a continuous river? So basically the factors that affect the shape of this longitudinal river profile are the climate patterns. Okay, so in long term, in millions of years or in thousands of years, this river basin might have faced different climate patterns due to the changes in the precipitation, which again affect the rate of erosion and sediment transport, and the tectonics, right? So with time there are earthquakes, there are uplift, there is subsidence along the faults, and there is a folding in the area. So how this river is behaving or changing its course because of the tectonics, because of the tectonics prevailing in this drainage basin. Rock type, maybe the river is flowing through hard rock or soft rock or the alluvium, so how it is changing its course, right? So we will analyze all these things when we talk about the longitudinal river section. And bedding planes also affect the course of the river or the shape of the longitudinal river profile. So you see the those distinct breaks that we saw in the previous profile are nothing but the nick points. So basically a nick point is a distinct break or sharp change in the longitudinal profile of a river, often manifesting as a waterfall, rapid, or a steep section. Nick points are significant because they indicate past tectonic activity, changes in sea level, or variations in lithology. So again, of course, you see if there is a tectonic uplift, the sudden uplift of the land can create nick points as the river adjusts to the new gradient. Changes in sea level, a drop in the sea level can cause a river to erode more deeply, forming a nick point. Okay, so it depends upon to what location you are finding or to which location you are finding these nick points. If you are if you have a transition of the resistant rock layers to less resistant rock layers, then you can say that rivers encounter hard, more resistant rock layers and forms nick point, because as they erode softer layers, because it is easy to erode the softer layers and that can be done more quickly as compared to the rivers eroding the harder or the more resistant rock layers. Okay, so any of these reasons can indicate these nick points. Okay, so if you see this part of the river, so you will find so many nick points, so many sudden break in the distinct break or sharp change in the longitudinal river profile. Okay, so there are so many along this river profiles, and when you analyze your data, then at that time you can check what could be the reason. So basically understanding the difference between bedrock and alluvial river profiles along with the significance of neck points provides valuable insight into the complex interplay between climate, tectonics and lithology. Okay, because all these factors are occurring all together and changes the shape of the landscape or evolve the landscape which you see at the present. Okay, so present day landscape is the result of the long term processes that are affecting it, okay, from thousands of years, from millions of years. So these imprints along the river profile can be used as a proxy to understand the landscape evolution. Okay, so this is the literature that I have taken help from, and now you can go to the next video to check out the step-by-step process which we can follow in QGIS to create these long profiles. Thank you so much.